Hey everyone, and welcome to Conquering Algebra 2. This is lesson 38. 3 concepts in this lesson. The 2 that we'll get to in a minute are going to be solving by factoring and any 0 equals 0, something like that. But the first one we're going to talk about is whenever we're having to not FOIL, but one step further, because notice this isn't squared, it is cubed. And so we're going to talk about the power of sums. So the big thing to remember with this is we're just distributing. We can't use the powers theorem, or I can just multiply x times x times x because it's cubed, and then 3 cubed as well, because these are being added. So what this is actually saying is this is x plus 3 times x plus 3 times x plus 3. And what we're going to need to do is we're going to need to multiply all of these out. So let's go ahead and act like this third one isn't here, and we're just going to work on these two. Let's see what that looks like. Okay, so in our first step, we are going to multiply x times x, which will be x squared, and then we're going to do x times 3, which will be plus 3x. So there's the first half. The second half is we are going to do inside times inside, so plus 3x, and then outside times outside, so plus 9. And the reason why I set it up like this is so that they are like terms and I can just add straight down. So now whenever I add these together, I'm going to get plus 9 plus 6x and then x squared. And what I have to remember is that this whole thing is being multiplied by this third x plus 3. So now I'm going to do the same thing I did up here, except instead of having 2 terms, I'm going to have 3 terms that this x plus 3 and this, or that this x plus 3 is getting distributed to. So we're going to rewrite this with this part moving up, and then we'll multiply that out. Okay, so now we are going to take this x and distribute it to all 3 parts in the second parenthesis. So x times x squared is going to be x cubed, and this will be plus 6x squared, and then plus 9x. Second part, we're going to distribute the 3 to the trinomial. So this will be plus 3x squared. Notice how my like terms are lining up beautifully. Plus 18x plus 27. Okay, so now we're going to add all of this together. And we are going to end up with x cubed plus 9x squared plus 27x plus 27. And this is it. There are no more like terms to be added. I can't remove any greatest common factor, can't solve for x, so this is it, we're done. This is our answer. Okay, so we're going to do another practice problem. Same setup, same premise, just so we can get a little bit more extra practice. So this is saying x plus 2 times x plus 2 times x plus 2. And we're going to focus on distributing, expanding these first 2 parentheses, and then we'll get to the third one at the end. So we have x times x, so x squared, x times 2, so plus 2x, plus 2x, plus 4. And when we add that together, we get x squared plus 4x plus 4. And now we are going to distribute that with x plus 2. Okay, so we have x cubed plus 4x squared plus 4x. So that's all distributing the x. And then we have 2x squared plus 8x, remember that we're multiplying, we're not adding, and then plus 8, and we add this all together, so plus 8 plus 12x plus 6x squared, and then x cubed. Nice! And so we did it, we have everything simplified, so we're done. Okay, so the second part of this lesson is going to be solved by factoring. And before we jump into this, I want to just point out the train of thought with how we solve here. If I had a times b equals 0, I know because of the multiplication property of 0, that if this is a situation, either A or B is going to equal 0, because anything times 0 equals 0. So it could be either of these combinations, but one of them has to be 0 if one side of my equation says equals 0. So keeping that in mind, we are going to, in these types of problems, get 0 on one side of our equation. So in this one, it's going to be on this side. We're just going to move the 6 over here. And once we do that, we can solve this and find out, okay, what possible values of x could create this situation to become 0. So let's go ahead and see what that's going to look like. Okay, so there's two things that I want to do in this first step. I want to move 6 over here, so I'm going to have to subtract. And then the other thing I need to do is I need to get this in order, in descending order of my exponents. So we are left with 0 on this side, and then x squared minus x minus 6. Now that we are here, we can take this trinomial and we can factor it into two binomials. And this is where we get into that setup that we were just talking about, where a times b equals 0. So when we do that, we're going to have x and x. The multiples, or the factors of 6 are 1 and 6, or 2 and 3. And we're going to pick that one. 3 is going to be negative, 2 is going to be positive. So now I'm going to split my problem. I need to find out what possible solutions of x would make either of these parentheses become 0. Because if this parenthesis becomes 0, 0 times this, it doesn't matter what this is, this times 0 will equal 0. And so that's what we're trying to find out. What possible combinations of x can I put in here that would make this statement become equal to 0? So we're going to split the problem in half. I'm going to focus on my first binomial first. So x plus 2, and I'm going to set it equal to 0. And when I do, I'm going to subtract 2 from both sides. So x equals negative 2. What that tells me is if I were to replace x in both of these parentheses with negative 2, it would look like this. Negative 2 plus 2, that automatically equals 0. So 0 times this, no, doesn't matter what it is, it's going to equal 0. So that's the first part. I solved x, the first part, and got x equals negative 2. So now I have x minus 3 equals 0. We're going to add 3 to both sides, and we end up with x equals 3. So these are my two solutions. The way I write my answer is x equals negative 2, comma 3. That tells us that either of these solutions, when plugged into this top equation, it's going to equal 0. And this is also where we could use the quadratic formula. Your calculator does have a program where you can solve all of this, which we'll get to that in a couple of videos to show you guys how to do that. But it's important that we know how to work it out by hand as well. So let's do another practice problem. Okay, so in our second problem, same situation, we have to get everything over to one side so we have 0 on the other. I'm going to move both of these because looking at all three parts, I see that this one has the highest exponent, and I want that to be positive because I know I'm going to have to factor into binomials. So that's why I want to move these two to the other side rather than just moving the minus 35x. So we have plus 2x squared and plus x cubed. So those are gone, and we have 0. And I'm also going to go ahead and put this in descending order. So we have x cubed plus 2x squared minus 35x. And before I start trying to factor into two binomials, I noticed that they have a common factor. So I'm going to take that out. They all can be divided by x. So now I take that out and I have x squared plus 2x minus 35 equals 0. Now I can get that into two binomials. So x times, and then we have x times x for 35. We're going to go with 5 and 7. And since 2 is positive, 7 will be positive and 5 will be negative. And now I'm going to do the same thing I did in the last problem. I'm going to split this up, and I'm going to set each of these equal to 0. Anywhere I have an x, I'm going to set it equal to 0. I'm going to switch colors just to help give us a little bit of variety. So with this first one, it's the easiest one to solve. We just say x equals 0. And then in the second one, we have x minus 5 equals 0. We're going to add 5 to both sides. So that's gone. And x equals positive 5. Last one, x plus 7 equals 0. We're going to subtract 7 from both sides. So x equals negative 7. So we have 3 solutions here. What we would write if this were our homework is we would say x equals 0, 5, negative 7. All 3 of those are possibilities that would create this equation to become 0. All right, so that is how you solve by factoring. Okay, so the last concept in this lesson is only 0 equals 0, which seems pretty simple, but we're gonna go ahead and show what exactly do they mean by that. In this one, we see that we have a greatest common factor of 2. So we're going to take that out and then factor into 2 binomials. So we have 2 and then x squared plus 2x minus 35 equals 0. Now we can set this into 2 binomials. So x and x. And then we have 5 and 7. 7's going to be positive, 5's going to be negative. Okay, so what they're wanting us to do is solve again. So we have x minus 5 equals 0, x plus 7 equals 0. And the point of this concept is us noticing these are the only 2 we have to worry about. I don't have to think that 2 will be a solution because 2 does not equal 0. Whereas in our previous example, it was x. X can equal 0, but 2 cannot equal 0. 2 equals 2. So with this concept, they want us to learn that if our greatest common factor is just a normal number, then it's not a solution. So my solutions will just be x equals 5 and negative 7. It will not be 2. And this would be our answer. Okay, so that's it for lesson 38. I hope this was really helpful for you guys. I know some of this really should just be a review of Algebra 1, especially solving by factoring. That definitely should just be a refresher for you. But be assured, rest assured that it will get more complicated. That's why they're going to start you up with these easier possibilities. So if you have any questions, if there's any confusion, leave a comment below. I'd love to be as helpful as possible. I'd be looking for that video for me to show you guys how to solve these in your calculator using a quadratic formula. And to my Algebra 2 students, I'll see you guys in class.